This time, guys, we need to apply the features that we discussed from the other videos about saving data, converting decimal to fractions, vis-a-vis, and what else? Yeah, making use of the default mode, and we will see the good thing about knowing those features. So let's make use of the example that we had in golden ratio. The problem there was that if we have a given length of 10, what would be the lengths of the two parts of this string, so that when we divide this longer side by this shorter side, we will get the golden ratio, which is the 1 plus square root of 5 all over 2, or approximately the 1.618033989. So we discussed in our discussion that to get the x, or the longer side, we have this formula. So in putting that in our calculator, so that's say negative 10 plus 10 square root of 5 all over 2. For those who have class B's or the other box over box calcu, you can have the fixed mode. Or for those who had a per key calculator, you will have the rounded off figure. Now here's the thing again, for those who are fond of just round off the figure, 6.1803, we will check later on how far it would be from supposedly 1 plus square root of 5 all over 2, or this decimal right here. So that now let's save this data later in letter X. Okay, so save that. So that's AC and equals, let's store that to letter X. It's there. Next, in getting L minus X, if you were the type of student who would be using the save feature of the calcu, you just have to press here 10 minus the save data in letter X, alpha X. That's why you will get the 15 minus 5 square root of 5, which is that 3.8196, or rounded off to 7. There. If you are using this calcu and say, or even this calcu, and you have not saved the data in letter X, that makes you subtracting 6.1803 from 10. This is the typical solution that students would have. They would say 10 minus 6.1803. There. Then you would say, Mom, we have the same answer of 3.8197. See? Oh, okay. Let's see if this would really help us all throughout, or would really give us more or less the nearest answer. But then clearly 3.8197 is really far from 10 minus X, right? This 601 is really far from 0.0007. Anyway, so yeah. By the way, 10 minus X, that one, let's save this to letter Y. So ans equals store Y. Okay, it's there in Y. Okay. In our discussion, again, if we divide the longer side, the longer part of this total measurement by this shorter part, or x over y, because we saved L minus x as y in our calcu. It says that the ratio of these two lengths would give us the golden ratio here. If you have not saved the data in your calcu and you would just rely on 6.1803 dx earlier, divided by the rounded off figure as well for L minus x or y, that's 8197. It would give us that. Yes, you will have same first 1.6180 because we rounded off to 4 decimal places, so significant figures play part here. But clearly this part right here is really far from this, right? Now, what if you really save the data, which is the nearest approximation, which is alpha x, or x divided by y. There, it's compact. There, the same magic. Now, it's just math. You might be asking, Mom, how about if I have this type of calcu? It won't give me the 1 plus square root of 5 all over 2. No problem, as long as you have this one. And you can still have this decimal right here, compact 1, if you will save this. So let's input that here. That's negative 10 plus 10 square root of 5, close parenthesis, for the numerator, divided by 2. That's your x. Let's save that to letter x, so that's equals shift store x. For y or L minus x, we'll do L, which is 10, minus the saved data in x, alpha x. It's there. Let's save that to y, and equals shift store y. So if we'll do x divided by y, so that's alpha x divided by alpha y. There. It will be the 1.6180 here. Same. Okay, so have the habit of saving data, alright?